Hey, today we're going to look at lesson 2.4 and talk about operations in scientific notation. We're not really going to spend any time in this lesson on add or subtract. If I was going to be adding and subtracting, honestly, I'd be using a calculator anyway. But we will talk a lot today about multiplying and dividing using scientific notation rules. And you'll see that right now today, a lot of it is just applying things that we already know and try and wrap up and make some connections between all of our exponent rules. So to start, first of all, you can do a lot of these things in the calculator, and there is something called calculator notation. And a lot of times calculators will display EE in a calculator. And what the EE stands for is it's sort of this part of the times 10 to the some power when we write something out in scientific notation. So 4.1 times 10 to the ninth, which is a 4, followed by a 1, and then 8 more zeros. In a calculator, it wouldn't look like 4.1 times 10 to the 9. You'll notice that there's an E right there, and that takes the place of times 10 to the. So it would look like 4.1 and then an E and a 9. That tells you there's 9 decimal places that you have to move. So if I wanted to turn this into calculator notation, it would just be, this right here is being replaced with an E or an EE. So it's going to look like 7.5 and then an E and then a 5. And it's a capital E, it's not a small e. And this right here is going to look like 3E minus 7. And it's going to look like that. There's no exponents or powers. When we write this, a calculator is not capable of doing that. Unless you have maybe a more advanced calculator. Old style scientific calculators all kind of function the same way, and this one's 2.7 E13. And you can see that we're just going to turn this process around, 4.5, and that E stands for times 10 to the negative 1 power. So this is 5.6 times 10 to the 12th power. And this one over here is 6.98 times 10 to the minus 8 power. And both of these, this last one here is a tiny little decimal. This one's not very small, but a little bit smaller. Let's go take a look at multiplying. Multiplying is really pretty basic. There's only one little trick. First, we're going to take the numbers that are out front. It is a multiply problem after all, and that says 3 times 2. 3 times 2 is 6. And then notice we have times 10 to the third and times 10 to the 7th. Well, the base is a 10. And we apply our exponent rules, and we're going to add the exponents. So it becomes times 10 to the, and then 3 plus 7 is 10. And this is correct in scientific notation. We don't have to do anything to it. So let's take a look over here. Again, we take the numbers out front, 2 and a 4. Multiply, after all, it's an 8. And then the exponents get added up. And that's a negative 6 and a negative 3. That adds up to negative 9. Now, when we come down to this problem, we're going to run into an issue because 4 times 5 is 20. And I'm going to go ahead and finish off the problem. 10 to the 5th, 10 to the 9th is 10 to the 14th. But it's not in scientific notation because this number is not between 1 and 10. So I know my decimal really is right there. And I got to move it back one place. And I got to make it a little bit smaller. It's just too big. So my final answer is going to be 2.0 if you want. You don't have to write the 0.0. But I made this number smaller. When I do that, I have to make this exponent bigger to balance it out. So when I make this number smaller, I moved it back. It's got to get bigger in the exponent. So times 10 to the 15th power. And that'll be our final answer on that one. And then this last one over here, 4 times 7 is 28. We're going to run into the same problem, but this one's got a negative exponent. We add up those two negative exponents, that's a negative 5. And my power, again, whenever I multiply, my numbers are always going to come out to be bigger than 10. I'm never going to get things to be smaller. Sometimes they'll come out bigger. My decimal is going to move back one place. So my new number is 2.8. And when I make this smaller by 1, this has to get bigger by 1. And that's times 10 to the minus 4. Let's take a look at division with scientific notation. It is a division problem after all. And so the first thing we want to do is take this 6 and the 3. Those are the numbers out front. We're going to divide those. And 6 divided by 3 is 2. And with the exponents, just like with before, we're going to follow division rules. The bases are both 10. And so we're going to take the two exponents and subtract them. It's always the top one minus the bottom one. So it's going to be 10 to the 4 take away 2 power. I wouldn't write it like that for a final answer. It's going to be 2 times 10 to the second power. Now, in this last problem over here, 9 over 3, 9 divided by 3 is 3 times, and then we got 10 to the power of, and we're going to do a subtraction. We got a little bit of a funky thing going on with all those negative numbers. It's top one, -4, minus the bottom one, which is a -2. And it's really important then that we understand that when we have two negatives next to each other, those become plus, and -4 plus 2 gives us a final answer of 3 times 10 to the -2 power. So that's all that there is to that one. Sometimes we get little decimals, and no need really to be frustrated by it. If you want to take 5.4 and divide it by 1.8 in a calculator, you can do that. It'll give you a nice pretty whole number. You can also do some little things to make these problems simpler to look at. This has one decimal place. If you want to pretend that that decimal just goes away because they both have one decimal, what you'd really be looking at is 54 divided by 18. And 54 divided by 18 is 3. So there's lots of little things you can do to make the numbers a little bit easier to look at. Times 10 to the power of, and then we just subtract those. 11 take away 5 is 6. We don't need to do anything else with that problem. And then the last thing that we're going to be asked to do, and this is kind of the 8th grade standard, is to be able to understand and explain orders of magnitude. How many times larger is one thing than another? And so the easy thing to do about this problem, the easiest way to start, is to look at these two and pick the largest one. In this case, the largest number is the one with the bigger power. It's going to be 4 times 10 to the 9. And so I'm going to put that number right over here, 4 times 10 to the 9. And what I'd like to know is, gosh, what do I have to multiply this by to get that? So I'm going to start with 2 times 10 to the 4. And now it's a matter of, like a puzzle, what number has to go here to give me a 4? And again, it's a multiply problem. 2 times 2 is 4. And then the next thing we have to decide is, what's the power on 10 have to be? It was 4 here, and I have a 9 here. And the question, how many more 10s do I need? And the answer is, well, 5, because 4 plus 5 gives me 9. So the missing number is 2 times 10 to the 5th. And so in short, our answer would say something like 2 times 10 to the 5th times larger. That's how many times larger that 4 times 10 to the 9th is than 2 times 10 to the 4th. Let's go take a look at another example. How many times larger than this? This is my smaller one. This one has the bigger exponent. So I'm going to go ahead and put that over here on the right side, the one with the bigger exponent. And I want to know, what do I multiply that by? That's a 1 times 10 to the 4. And now the question is, what goes in the parentheses? Well, there's a 1, and it's also a 1, and 1 times 1 is 1, so this has to be a 1. And now we're just going to go ahead and fill in the rest, times 10 to the, and what's the missing power? Well, it was a 4 here, and here it's a 7. I'm missing 3 more 10s. So the answer to this, it's 1 times 10 to the 3rd larger. In standard form, that's 1,000 times larger. This right here represents 10 million. This right here represents 10,000. And 10 million is 1,000 times larger than 10,000. The last thing we could do sometimes is represent this in a word problem. And so here we have Disneyland with 9 times 10 to the 4th visitors a day. That's a lot of visitors. Butte County, not very many go to the Butte County Fair by comparison. So this is the larger number, and we're going to go ahead and put that on the right-hand side of the equal sign, 9 times 10 to the 4th visitors. We want to know how many times larger Disneyland's crowd is than Butte County. And so Butte County is that smaller number. We'll put it over here, and we're going to try and figure out what goes in the middle. Take a moment and just look at that and try and figure out, how am I going to turn a 3 into a 9? And the missing number here has to be a 3, because 3 times 3 is 9. And now, what's the power on 10 have to be? Well, it was a 3 there, and it's a 4 there. I only need 1. You can write it this way, 3 times 10 to the 1. In scientific notation, that's fine. In standard form, If you remember from the last section, that when the power is 1, I got to move it one place over. And in standard notation, what that really means is that a Disneyland crowd is 30 times larger than the crowd at the Butte County Fair. Now you have enough information to go complete your lesson. Good luck.